Okay. So when I was walking around at the what do you notice, a lot of you noticed that these were all positives, like addition in the binomials, and these all had subtraction in the binomials. That's cool. Okay, so here the signs are the same. Here the signs are the same. Do you notice something special about both sets of foiled out answers?
Well, technically, A, they're the same equations except subtraction, and B, they always seem to have the same answer except the opposite.
Okay. What is the only thing different of these two answers? What is the one difference?
The sign.
Where?
It's between the plus, like in the first one, it's between the X and the 3 and the X.
Okay, so whatever the X is.
Yeah.
Okay, notice how these are all positives and these are all negatives. Okay, let's talk about why that's happening. Okay, well, when we FOIL this out, everything's positive, right? Because everything's positive. Okay, over here, X times X is going to be X squared, but a negative times a negative is going to make our positive, right? So those are positive. Negative times a negative is a positive, but then our O and our I are going to be two negatives that we add together. Okay. Now, I really encouraged you to think about the relationship with these two numbers, like 3 and 4, compared to what we have right here. So did you make any of those observations? Okay, who would like to share that observation? Amy, you shook your head. What did you notice? Did you not? Did you find a relationship with the 3 and the 4 and the 7 and the 10? Okay, good. Okay, and what else did you figure out? You shook your head, I thought.
I don't know. Like these two are both positive, we make two positives, these two are negatives, let's make it positive.
Okay, I like that.
You're just adding the 3 and the 4 together.
Okay, so this is 3 plus 4. And Peyton, what's this?
That's 3 times 4.
Oh. Is this 2 plus 5? Is this 2 plus 5? Is this 2 times, excuse me. Is this 2 plus 3?
Yes.
Is this 2 times 3?
Yes.
Is this 1 plus 5? Is this 1 times 5? Okay, so let's continue this. Is this negative 3 plus negative 4?
Yes. Yes.
Yeah. And this is negative 3 times negative 4?
Yes.
Is this negative 2 plus negative 3?
Yes. Yes.
It's not?
Yes.
Okay. Negative 2 times negative 3?
Why are you looking at me?
I'm just looking into this. Okay, so now let's go to these. Okay, so Peyton said, this is what Peyton noticed. If you have one that's negative and one that's positive, this term right here is going to be negative. Do you see that?
Yes, I do.
Okay. Now, up here, we added these two numbers to get this middle guy. Do you think that's still going to work? What's negative 3 plus 4? 1. What's 2 plus negative 3? Negative 1. What's negative 1 plus 5? Whoa. Whoa. Okay. So raise your hand if you figured out what two binomials multiplied to get this. Andrew, what'd you get?
X plus 2 and X plus 5.
What's 5 plus 2? 7. What's 5 times 2? 10. So what about this one? What has to change here? If this is subtraction, but this is a positive number, what changes here, Sophia? Okay, a negative times a negative gives us that positive, but since they're both the same sign, okay, that's gonna affect this. Now, and this third one, our constant is a negative, which means we're gonna have x plus something and x minus something, is what you told me. X plus what? X plus 2, x minus. Okay. If you didn't quite get there, it's totally fine. If you did, awesome. Okay. What I'm going to have you do, keep that out because this might be helpful. I want you to turn in your student journals to page 226. I know you're not. What? We need. 226.
Those things is giving me positive 226. Took me a second. Okay.
So we are working on what's called factoring. We are working on what's called factoring. We are going to take a trinomial and we're going to write it as a multiplication problem. So I don't know if you noticed my little hint on there. We're basically unfoiling, which sounds awful. It's called factoring. We're going to write it as a multiplication problem. Okay. So I want you to right here. Okay. If we have something like this, we FOIL. Okay. And when we FOIL, the F gives us this x squared. The O plus the I add together for this middle term. And then our last term gives us that constant. Okay. So we're trying to think of numbers to place here where when I FOIL our last term, so 1 times 5 gives us this 5. But when we FOIL the outside and the inside, 5 times x, 1 times x are going to add together to get this number. Okay. Same thing here. Okay. What is nice is when our last term is positive, that means both binomials are going to have the same sign. They're either both going to be positive or they're both going to be negative. Okay, so let's just think of this right here. I want you to write this down with me. I want you to write down x squared plus 9x plus 18. Okay. All right. So first thing, since this is positive, we know that they're going to have the same sign. Specifically, since this is positive, along with it, our outside and our inside product will both be positive. Okay, that's great. Okay, so I'm going to write this. I'm going to write x plus x plus. Okay. I know that these are both positive. They're the same sign since our last product is positive. Okay. Since this is also positive, they both have to be positive. So now we need to think of what number multiplies to 18 and adds to be 9. Remember, this is our O plus I. So I need two numbers that add to be 9, but they also need to multiply to be 18.
6 and 3.
Okay, so you're saying 6 times 3 equals 18, and 6 plus 3 equals 9. Jane says, excuse me, Preston says, I think so.
What?
You said, I think so.
Yes.
You know how we can check to make sure we're right?
Foil.
We can always FOIL to check our answer. What? Why?
Because you mixed up our names.
Oh, sorry. So F O I L. Ooh, did we get the same thing?
Yeah.
Yeah, we do. Yeah, we do. Okay. Good job, guys. We did it. Glasses. Put them on. They're right there. Put on. Okay, so let's talk about this one. X squared minus 9x plus 20. Well, since this is a positive,
It was positive and then negative, would it be negative 9?
okay, so if the constant term is negative, we have 1.
Okay.
Okay. All right. Since the constant term is a positive, we know that O and I will have the same sign. Okay. Since this is negative, well, that tells us what our sign is. So we know we have x minus something times x minus something. Yeah. Not there yet. Okay. All right. So I want to know what multiplies to a positive 20 and adds to a negative 9. So what is your idea? Okay. And I'm going to go ahead and use these negatives in there too. Okay. -4 times -5 equals 20, right? -4 plus -5 equals -9. Okay. And if we want to check ourselves, we can FOIL and make sure we did it correctly.
Algebra was probably easy for the Romans because X was always 10.
Thank you. Okay, so now let's talk about what happens when this term right here is negative. Okay. When this term is, so this is our FO plus IL. When this term is negative, that means we have one positive and one negative in our factors. Okay, so we're gonna have to think just a little bit harder. Okay. So like in this example, +1 times a -5 gives us the -5. +1 plus a -5 is here, this -4. So let's think about this one. X squared plus 5x minus 14. So notice how this guy's negative. So O and I will have different signs. Okay. So we are going to take, okay, this is our last product. I want to know two numbers that multiply to equal -14 and they add to equal a +5. So this is what I would try to do. I would think of, okay, what numbers multiply to 14? Well, we have 1 and 14, 2 and 7. Oh, 2 and 7, that kind of sounds nice, right? Okay, so I know that 2 times 7 equals 14. So now I need to think about if we want to equal a +5, which one needs to be negative? 2. So if the 7 is negative, what's 2 plus -7?
-5.
That'd be a -5. We want the 2 to be negative. So x minus 2, x plus 7. Interesting. Now, let's try this one. X squared minus x minus 12. Is that really the example that I chose? Whatever. Okay. Now, notice how since our L product is negative, we know O and I will have different signs. One's going to be positive, one's going to be negative. So when we're thinking about what multiplies to -12 and adds to -1, right? This is like a 1 right here. I need to think of two numbers, one's positive and one's negative. Okay. So when I think of numbers that multiply to 12, I'm thinking of 1 and 12, 2 and 6, 3 and 4. What is it? Okay, so we know that 3 times 4 is 12. Now, if I'm going to add those two together to equal -1, which one's going to need to be negative?
3, 4, 4.
The bigger number is going to need to be negative since our answer is negative. So +3. Okay. Hey, guess what? As long as you check yourself, you can guess and check.
Yeah.
Like you? Okay. Think to yourself, what's -3 plus 4? Oh, that would be a positive one. I better put the negative with the other guy. Okay. Check yourself. All right. Turn the page. You, just glance over. You and your elbow partner are going to factor 1, 3, 7, and 9.
7 and 9.
1, 3, 7, 9.
Okay.
Yeah, it's a U.
That is 2, not 3.
Go with the Lord.
Yeah, okay, so it's been. No one would be. We don't know yet. I mean, we have to like, kind of,
We're about to move on, okay?
Why are you taking your face something? Not favorite. Not favorite.
What?
You said fake. I did not say, I said the B word.
Right, so I stand the whole way up for everybody.
Wait. That would be B2 plus 9. That's my B minus 6. Yeah, okay. Yeah, 6.
All right, Nirvan, what do you have for number 1? Okay, let's check him. First, outside, inside, left. The same thing?
Yeah.
Sure is. All right, good job, Nirvan. Okay. Number 3. Reagan, what'd you get? If we FOIL that out, we'll get back to the same thing. Okay. So what about number 7?
I had B minus 6.
Okay. And then, Maddie, what about number 9? Love it. Okay. Now, what's the purpose of this? This just seems like a waste of time right now. Okay. I'm going to tell you. Okay. What if you had a polynomial equal to 0? Now you can turn the page. Okay. If we have a trinomial that's equal to 0, well, we know this cool little thing called the zero product property, that if I have 2 things multiplied to 0, we know they have to be 0. Okay. So first of all, let's factor this guy right here. I need 2 numbers that multiply to 40 and add to negative 13.
8 and 5.
Would they both be negative?
Yes.
So G minus 5 and G minus 8? Is negative 5 plus negative 8 negative 13? Is negative 5 times negative 8 positive 40? Okay. So now if we have 2 factors that are multiplying to equal 0, then we know one of them or both of them have to equal 0 because of the zero product property that we did on our course last week. So this means G equals 5, and this means G equals 8. So now we can actually find solutions.
Wow.
Why?
Why?
Did you ask why?
No, I thought the
It is a G. So. These are trinomials. Yeah. Okay, so how about this one? If I can factor this and I have a multiplication problem that equals 0, man, that's pretty nice. So I need two numbers that multiply to a positive 10, but add to a negative 7. Positive or negative? Negative 2 and negative 5. Okay.
Thank you, Brett.
And when we have a product that equals 0, then we can set each one of them equal to 0. Now, here's the trick. Do we have something called the 3 products property? The 8 products property? The 30 products property? No. We only have the 0 product property. So if I'm looking at number 16 here, I can't do anything with it unless it equals. So if it doesn't equal 0, my first step is to rearrange that equation to where it equals 0. So I'm going to take 30 and I'm going to subtract it to both sides. So now, number 1, I have a trinomial over there on the left. Number 2, most importantly, it equals 0. Now we can FOIL. What do you mean leave it? Because there is only one product that equals 0. Whereas like we can think of a bunch of different products that equal 30. 1 times 30, 2 times 15, 7.5 times something. Okay, 0 is the only product that we know there has to be a 0. Okay, so what multiplies to negative 30 and adds to negative 1? Which one's negative?
6.
Okay, I have differing opinions. Which one's negative? 6 is negative. The bigger number needs to be negative if that middle term is negative.
Encourage mistakes there.
Yeah,
It's right up there.
Making
Don't laugh at
mistakes is
me.
fine.
making mistakes.
Once we have a product, once we have this factored, if we have a product that equals 0, we can set each factor equal to 0. So our answers are negative 5 and positive 6.
She added the other way.
Oh, my bad.
Okay, so your homework comes from page 389 in the textbook. So it's something that I will put on Google. No, that's your student journal. It's something I will put on Google Classroom. Yeah, so that there's your sign, right? I have to put it on Google Classroom. Your green sheet, you can keep and recycle, but don't leave it on my table. What is happening? I heard.
I did not hear anyone say that. I know you didn't